Okay, guys, so let us continue. Okay. So we were talking about the different factors affecting the consumption of hot water. Okay, and we need to know all these factors in order to design the appropriate solar water heating system. Now, in this figure, we can see the different components of an active solar system. Okay, so we have already we have seen that the main components are the collector, the thermal storage system, and the distributing system. So here we are showing several scenarios of operation. So first, let's say during the day, during sunny hours, the temperature inside the space is relatively high. So no need, if you want, no need to use the solar energy now. And if you use it now, this might lead to overheating of your space. So in order to benefit from the solar energy without overheating our space, what we can do in this case, we will create a certain distribution system that will allow, if you want, the circulation of water in a way that is convenient for us. So if you look at the figure here, for example, what will happen during the day, I don't need to heat my the air inside my space. It's relatively warm already. So the energy collected from the sun will be transported through the fluid, and this fluid, as you can see here, will go over the a thermal storage material. The thermal storage material will extract energy from the fluid, okay, and will store it to deliver it when needed. So here, as you can see, no heat is transmitted to the space because the temperature of the space is relatively good. Okay, and now once, if you want, once the solar energy is needed inside the space, what will happen is that once the temperature inside my space begin to decrease, okay, then I can use now, instead of giving the energy to the thermal storage, I can directly give the energy from collected from the sun. I can distribute it directly to my space. Okay, so by opening certain vents, then I can, if you want, circulate my a second. And here you can see another path. Okay, in this path, you, instead of going towards the thermal storage system, your fluid will go through, let's say, a heat exchanger that is directly related to the inner space. So by taking your fluid here, it will heat air, or it will heat air, and the air will be circulated in my space to heat it. So here you can say that I am directly heating my space from the solar energy. And during night, I don't have any more the solar energy, and the temperature inside my space will begin to decrease. This is why what I can do now is I will start to circulate air around my thermal storage place, where here the air can be heated from the thermal storage, which will deliver energy to it, and then air can be transmitted back to the space. So here we have three scenarios. The first one where we have excess of heat, then we store solar energy in the storage medium. Then another case is when the solar energy is directly needed to heat the space, so we don't take it to the storage medium. And at the end, when solar energy is not available, then air can be circulated through our storage medium that can be delivered back energy to the air. Now, another important application of solar energy is solar chimney. A chimney uses convection effect, okay, in order to circulate to heat a space. Okay, so it consists, if you want, on it's based on relying on convection of air to heat a certain space. Okay, now another possibility. يعني, what is the concept of solar chimney? It rely on Bernoulli principle and stack effect. So here you have two possible effects. You have or Bernoulli principle or stack effect, and we will explain each type of these two. So if you remember, when we introduced Bernoulli's equation in previous chapter, we said that if you remember the equation, okay, it was of this form: pressure plus rho v square over 2 so rho v square over 2 plus pressure plus plus rho g z equals to a constant. This was the Bernoulli equation, if you remember. Okay, if you look at this equation and you neglect, let's say you neglect variation in altitude, if we don't have very large variation in altitude, if you just compare these two terms, rho v square over 2 plus p is constant. This means what? That if you have a high velocity, pressure will be reduced. This is the Bernoulli effect. So if I have air moving at high velocity, I can create a low pressure, and due to the pressure drop, I can circulate my flow. Okay. So for example, the Bernoulli's principle can rely on using wind speed differences to move air, because due to when you have wind, the velocity of wind is relatively high, which will create a low pressure for this flow, and therefore due to the pressure variation, okay, you can create motion of your fluid in your system. Okay. So you can mainly you can mainly benefit from Bernoulli's principle in case you have wind. So due to wind effects, you can have circulation of air in your space in a simple way. Now, because the faster air moves, the lower will be its pressure, and lower pressure can help to suck fresh air through the building. Now, the advantage of Bernoulli's principle over the stack effect, okay, when we say just stack effect, when we talk about stack effect, it means that we just rely on variation in temperature, because you know that if you have variation in temperature, which is equivalent to buoyancy, what will happen is temperature increase will lead to decrease of density, which will lead to motion of air. So you can have motion of air by two effects, or by pressure drop, which can be done by increasing the speed, which can be obtained when we have wind. And the second effect, even if we don't have wind, if we heat our air, due to heating effect, the density will be reduced, and then due to buoyancy, it will move upward. Okay, so in stack effect, we mainly rely on a change in density due to temperature variation, while in Bernoulli's principle, we rely on change in velocity. So, for example, when we have wind, in order to create a certain pressure drop that will circulate air. Okay. Now, the advantage of Bernoulli's principle over the stack effect is that if wind exists, it multiplies the effectiveness of ventilation due to differences in pressure it creates. So, when you have wind, this will add the effect of pressure difference. So this is the an advantage of Bernoulli's compared to stack effect. On the other hand, the good thing in stack effect is that even if we don't have wind, we can have a motion of air due to temperature difference, due to buoyancy effect. Okay, so we will see this in more details in the following slides. Guys, just 1 minute. I want to put the charger. Okay. So now let us see in other slides in detail these two aspects. So for the stack effect, it will use temperature differences to move air. Hot air will rise because it's lower pressure. For this reason, it's sometimes called buoyancy ventilation. The advantage of stack ventilation over Bernoulli's principle is that it does not need wind. It works just as well on still breezeless days when it may be most needed. And you know that in general, we need ventilation not on days where we have wind. We mostly need ventilation in cases where we have high temperature outside and no wind currents. So this is why stack ventilation is very important, because even if we don't have wind, due to temperature variation, due to increase of temperature, Reduced density will lead to air motion. And we will see the operation of such systems in heating and cooling season. So we can see that these effects can be used in not only in cooling but also in heating season. So let us see how these systems operate. Okay, so first let us consider the heating season. In the heating season, what we will do, so here you have, if you want, both here rely on stack effect on rise of air due to solar heating. So as you can see here, you have a facade. This facade is exposed to sun. Okay, so in general, we put our system here in on a facade that is exposed uh, a high number of hours to sun, even in winter. Okay, so what will happen here, that during winter, what we do is we close openings. All openings like doors, windows will be closed. And what we open only the inner vents of our facade here. Okay, so these two are opened, as you can see, the lower and the upper one. And then air will circulate from the room. So air will go first, will be drawn through this gap like this. Okay, and once it goes through this vent, it will be heated by the solar energy, and due to stack effect, it will raise upward due to decreased density, relying on buoyancy effect. So it will go up, and then it will be, since you are closing all your external vents, so here it's closed from this side it's closed, so it will circulate back into the house, and this will lead to a warming effect. Okay, so in heating, as we said, we have these four main issues. First, the exterior vent and building opening should be closed. Then air will be heated in the chimney column due to a stack effect. And vent here are closed so that air cannot flow outside, it will flow inside the space. And in this way, reheat will occur in cycles, so air is drawn back and forth into the chimney. On the other hand, in summer or in seasons where we need cooling, what we do is first we should open, and we should have the opening should be opened, windows, doors, because this will allow for outdoor fresh air to circulate inside the space. And then this air will go through the lower opening of the solar chimney. Okay, and as it goes through the chimney, it will be heated by the solar energy, and then it will exhaust our space. Why we do this? Because this will create fresh air currents, and fresh air currents in your room air will lower the temperature in your space and will make you comfortable, because fresh air is continuously entering your space. So in cooling application, the external vent and building opening are opened, and hot air is pulled outward. We close the vent here because we don't want hot air to circulate back in the space. Since we don't want to heat the space, we want to cool it, we want to refresh air. This is why the air that is heated through the chimney will be evacuated outside. And by this, as you can see, you have open currents that can circulate into my inside space, refreshing air continuously. Now, one of
Miss,
the,
can you re-explain the stack effect?
yes, the stack effect just rely on heating and rely on increasing temperature for air motion. Okay, because you know that when T increase, so if you have air and when air will pass through the solar chimney, what will happen? So when you draw air to this side here, when it goes through the chimney, it will be heated by the solar energy. So the temperature will increase. And because of temperature increase, what will happen? So the stack effect mainly is due to this. So stack effect. So what we have first, we have temperature increase. So T increase. When T increase, rho, which is the density, will be decreased. Okay? And due to decreased density, so due to buoyancy effect, and therefore due to buoyancy effect, air will move upward. Okay.
Miss, how is this related to Bernoulli's theorem? This is the buoyancy.
No, Bernoulli is related to wind circulation, not in this case, because when you have wind, okay, when you have wind, you create a certain pressure difference between two zones, and due to pressure difference, air will circulate. Okay, يعني,
Okay.
this is what we are explaining now is mainly stack effect. And when you use a solar chimney, it's mainly based on stack effect. When you have wind, okay, you can rely then on Bernoulli, because due to pressure difference, when you have wind, you just open your windows, okay, and by opening your windows, air will circulate due to pressure differences.
But in the second case, opening مش كأنه you're opening a window.
Yes, but مش ضروري يكون عندك wind. This is what I mean. Even if you don't have wind and you have here an opening, air will circulate. Okay, can circulate inside the space, because هلا أكيد if you have wind, your efficiency will increase a lot. Why? Because you will combine the pressure drop effect to the stack effect.
Okay, and then the question before with Bernoulli, we put V equals to 0 or no, V1 equals to V2. That's why we cancel them.
No, I didn't cancel anything, but I said that Bernoulli states that P plus rho V square over 2 is a constant. This is the Bernoulli statement, okay? So because it's a constant, when you have increase in velocity, what will happen to pressure?
It will drop.
It will drop. So this is why when you have wind, you can create pressure drop effects, which will allow for circulation of air.
So you create pressure drop effect because you raise your because you
Because
play
you
with
have
the velocity.
yes, because you have a higher velocity.
So you have the higher velocity on the inside or the outside? The outside.
Yes, look, whenever you create difference in velocities, even in this, when you have wind and you open your windows, okay, so you will have circulation, you will have due to a motion of wind inside your space. Then inside your space, you will have difference in pressure, because the pressure of the air coming in is high, while pressure inside the space might be relatively higher. This will lead to circulation of air in your space, because due to pressure drop, you will have tendency of air to go from high pressure zone to low pressure zone. And just when you open your window, because of the low pressure outside, air will circulate out. Okay, and this will lead to convection currents from outside to inside and from inside to outside. So air will circulate. So first it will leave from your house, and when air will leave your house, another part will be sucked from the external space, and this part that is sucked will have a lower pressure, and this will cause, if you want, cycles, because you will create pressure drops in your space, which will lead to continuous circulation of air.
Okay.
Okay. Now, for solar air heater, what we have here, it's like solar water heater, same concept, okay? But we use, instead of water as fluid, we use air. In general, this system, the benefit of it is that the cost is very low. But as efficiency, it's not very efficient, because you know that air, the heat capacity of air is smaller than water. Okay, so the specific heat CP of air is smaller than water, so the ability of air to store energy is lower. But it can work for applications that does not need a very high amount of heating. Okay, and the main benefits are it's a very simple system to install, and it's the cost is very low. Okay. So the solar air heater is the cheapest and most widely used solar energy collection device, and it's mainly used for drying agriculture products. And so in these applications, you don't need very large gradient of temperature. This is why it's very used in such applications. Now we have several types of solar air heater. You can place them on the wall, and they will have the same concept. It's similar to a solar chimney if you want. Okay, but here, as you can see here, the operation is in the reverse side. So what you do, um, you can use them in winter to heat your space, because you will take cold air from your room, and when it goes through your facade here, it will be heated, and then it can be supplied back to your system for heating purposes. It can be also roof mounted, so you should put it on a location where it can absorb solar energy. It can be at the roof, it can be on a facade exposed to the sun, etc. Now, the advantages of such system is that it's simple in design, it's cheap, it's a free energy source, it requires little maintenance, and since air is circulating, so you don't have water, you will get rid of the two main disadvantages of water, which is corrosion and freezing. And concerning the disadvantages, we know that air has a low thermal capacity, so we cannot use the system for very high amount of energy needed. We have fluctuating energy source, so solar energy is not always available at all times, and we need the ducts and free space. Another important application of solar energy is photovoltaic effect. So as your friends have introduced in their work today, PV cells mainly convert sunlight directly into electricity. So the photovoltaic effect gets its name from the process of converting light to electricity, which is called the PV effect. And from here, we have the name of PV cells. So in summary, how this operates, and also your friends explained a little bit this. So when sunlight strikes a photovoltaic cell, electrons in a semiconductor material are freed from their atomic orbits and flow in a single direction. This creates direct current electricity, which can be used immediately converted then to alternating current or stored in a battery. PV cells normally have a lifespan of at least 20 to 25 years. However, they usually last longer if frequent overheating is avoided. Okay, so always we should cool PV cells because their efficiency decreases with temperature. PV systems can be used as a building sole electricity supply or with other sources such as a generated or a grid connection. Now, the main disadvantage of PV cell first was the very long payback period. So we need a lot amount of time to on the economical side to be satisfied, because to start to gain we have a very long period, and this was improved with time. يعني, research is undergoing in this field to enhance the efficiency, and by enhancing the efficiency, the payback period will be reduced and these systems will become more viable economically. So photovoltaic systems consist mainly in semiconductor material that converts solar energy directly into electricity. Autonomous PV systems with battery storage are found. We have hybrid PV systems that have at least one additional electricity source. So as we said, sometimes we can combine any solar system with another system, such as fuel-fired generator or a wind turbine. And currently, what we are using a lot is grid-connected PV systems, because by connecting them to the grid, we can, when we have excess of solar energy, we can give to the grid energy. And on the other hand, when solar energy is not enough, we take from the electricity grid energy to the to operate, if you want, our house. Okay, so in this way, we can maintain a constant amount of electricity provided to our system. So hybrid PV systems have at least one additional electricity source operating with them, and grid-connected PV systems cancel out the need for on-site generators and batteries and eliminate the problem of intermittent solar energy. Now, based on the annual growth rates of nearly 20%, the break-even point for competing with bulk electricity generation was calculated to be between 2020 and 2030. This was based on lowest production cost, but does not consider technological advancement or the advantage of reduced greenhouse gas production. So with time, we are increasing a lot the efficiency of PV such that it will become a very important source that can replace the the fuel energy systems. Now, for photovoltaic hybrid heating system, we said that we can combine them with another system, or also what we can do is we can profit from lost heat from PV, because we will see together that the percentage of energy converted to electricity in PV is not very high. And it's true that research is undergoing to increase this percentage, but also if we can benefit from the lost heat in PV systems, we can increase a lot the efficiency. Okay, so for example, a typical crystalline silicon PV panel has an efficiency of 10 to 15% in electricity energy when we talk about electricity energy. So PV solar panels produce more than 4 times as much heat as electricity. And if we just use electricity, it's not a good efficiency, 10 to 15%. So if we want to use PV in a more efficient way, we should extract also the heat that is lost by PV panels. So a PV cell can have a stagnation temperature of 50 degrees above the ambient if the heat is not removed. And since also temperature is harmful for the efficiency of a PV cell, so a double advantage uh, of taking the heat of PV cell is first that we can benefit from the lost heat, then we can reduce the temperature of the PV cells, and therefore their efficiency and production of electricity will increase. So drawing outside air in across the back of panels preheats the HVAC supply air and also increases the PV efficiency by keeping them cooler. Combining these two systems produces both heat and electricity, which is equivalent to a cogeneration power plant. So if you remember, what is the meaning of cogeneration? When we use two different systems combined together, okay, to increase the efficiency, as was the case for combined gas turbines and steam turbines, if you remember. Now, the payback of a grid-connected PV electrical system was decades. So before, when we started with PV systems, when we say a payback period of decades, so it's not practical at all. No one will install the system if we need decades to get back the money. Okay, this is why undergoing research was done in order to enhance the efficiency of PV systems to make it economically viable. And by 2010, the cost of panels had fallen to $450 per kilowatt per peak. And of course, now it's much better. Now, we have several types of photovoltaic system. As your friends also introduced today, so you can have several materials. You can have single crystal, polycrystalline, amorphous film. So you have several types, and depending on your application, you will choose the corresponding type. So for example, single crystal represent a very high efficiency, but the disadvantage is that you have a high cost. It can be corrupted easily, and for the cost, it's nearly $5,000 to $10,000 per kilowatt, and the efficiency is between 11 and 15%. For polycrystalline type, you have also a high efficiency, same disadvantages, nearly high cost, and can be corrupted easily. And you have the capital cost is also relatively high, $5,000 to $10,000 per kilowatt, and the efficiency is between 10 and 14%. For other types, as you can see, you have a lower efficiency. Okay, so for amorphous type, it is between 5 and 8%. So, but the advantage is that it's flexible and can be applied to different types of surfaces. So depending on your application and the efficiency required, you will decide on which type to use. Now, concerning the structure of photovoltaic panels, you have the small element is the PV cell. And if you arrange PV cells together, you get a PV panel. And by arranging several panels close to each other, you get a PV array. Now, how to integrate photovoltaic cells? You have several designs, and in architecture, we try to have them in a nice way. So as you can see here, you can integrate them to building facades. You can put them on roofs. Okay, so photovoltaics materials can be placed on the building envelope instead of the conventional materials used as the building skin. and this will have the advantage of higher, we can benefit from a higher surface area, and we can generate more electricity. Now, as we said, photovoltaic cells are very important, and they are advancing a lot with time. And for example, on the 24th of September 2013, we have a new invention consisting on converting sunlight into electricity using a new solar cell structure with 4 solar subcells. This structure will help in concentrating solar energy and increasing the amount absorbed. So after 3 years of research, we recorded an efficiency of 44.7%, measured at concentration of 297 suns. So we increased a lot the efficiency of conventional PV cells. So as we said, with technology and with time, we are reaching higher and higher efficiencies. Now, finally, a very important application of solar energy is solar thermal storage. Okay, so storing the energy of sun, especially when we don't need it, and during the summer, during a large period of time, we don't need the sun energy, so we can take it and store it in a place where we don't have heat losses, and then when we need it, we can restore it back to the space. So, for example, some projects use large solar arrays to collect heat in the summer and store it in large, well-insulated underground water tanks. So you can build underground water tanks, and this way you can use water from season to season, the heat stored in these thermal storage places. So the heat is extracted from the water during the heating season. They use approximately 10 meters square to 20 meters square of collector and 20 meter cube to 40 meter cube of storage for every flat or house. So here the disadvantage is you need a very large amount of space. Okay, so you need to go underground first to have a very large volume underground, and to have the possibility to store heat. But on the other hand, you can benefit from the solar energy during hot seasons and use them in cool seasons. Performance projections indicate that they would provide from 30 to 60% of a building's energy. So they can save a lot of energy if implemented to buildings. So mainly, this is the chapter on solar energy. Okay, we are done with this chapter. We still have the last chapter in this course material, which is on an economical assessment of a project. So I will start it now, and we will be done with the material. So as I said, I will post for you a small assignment to practice on these chapters, and we will solve it together. We can set a time that is convenient for all. So I will talk on the group to set an extra session because we had the Monday holiday. Okay, so we will do it maybe on Friday on a time that is convenient for all. Okay, so
Yes.
now let me open a new session.
Miss, before you open a new session,
Yeah. Yes, sure. Tell me.
So basically, the last 2 chapters we didn't solve any problems in them. They're going to be, the MCQs
Yes,
are
look,
going to be,
now in the problems will be mainly on solar systems, because you can have sizing, for example, and the problems will be very simple. And you just need some logic to solve them. You don't have a lot of formulas. And for the economical chapter, I will do a very important example, including everything in it. So the questions in the exam, questions will be, I will give you samples of that. Now, in this assignment, I will give you sample problems, which will be the type given in the exam. Concerning the other chapters, the questions will be multiple choice, and for wind energy, for hydropower. Okay.
yes,
So you should just understand the concept. Yeah.
Because there's a lot of information on the slides, and to what extent are we supposed to know what's
like the previous exam. For the previous exam, if you just understand and read the material 2-3 times, you can answer. No need to memorize. And I don't ask questions specific number, year. No, of course not. I ask questions on concept. So if you understand the concept and if you read 2-3 times the slides, it will be like exam one. Same strategy.
Okay.
No need
Yes,
to
can you
memorize anything. And no numbers, no dates, no very specific issues. No, but just general information and concept. And if you understand the concept, you can respond to the question.
Miss, I'm sorry to interrupt. Can you please say again what chapter will be problem solving and what problem will be
Yes. Mainly the
Right.
problems will be on the last two chapters, solar energy and the economical analysis. For the other chapters, it will be on the information that we introduced in the material, and just multiple choice questions. And just on 7 and 8 we have problems, and I will put an assignment for you to try to practice, and we will correct it together in the next session that we will do
Okay,
on
thank you.
Friday maybe. Okay?
Thank you. Thank you, Doctor.
Yeah, so I will
Miss,
open
do we have a next session? Isn't this the last session?
it should be the last session, but because Monday was holiday, so we need a makeup session. Okay? يعني Monday we
when will
didn't. نعم.
When will we do the extra session?
This week. هلا we will talk on the group. We select a convenient time for all and we do it. I am available
Okay.
anytime. We can do tomorrow on Friday. It depends on you. What time is convenient for you? Okay. يلا we'll open now a new session.